My name is Baltazar and I'm going to be your calculus mentor for today. Someone had sent me an anonymous letter asking for help about a topic in calculus. She or he had sent his message in a form of a code. Good thing I solved it, and it looks like that my sender is needing help in ellipses. In this video, you are going to learn more about ellipses and how to solve them. This is Baltazar again, and you are tuning into the tutorial video for ellipses. So here I am today with the lesson on all about ellipses. Ellipses are part of a four-part lesson on conic sections. So this is the third part on ellipses. It is part of the pre-calculus lessons for grade 11. My name is Baltazar and I am here to tell you all about ellipses. Throughout the remainder of this video, you are going to learn more about ellipses and not just only its definition, but a whole lot of things. So first of all, what will you learn? First of all, the definition of the ellipse. Next, the parts of the ellipse. Next, kinds of ellipses, horizontal and vertical. After that is the equations of ellipses, both general and standard. Here you will learn to transform a general equation to a standard equation and vice versa. And last but definitely not the least, the practical applications of ellipse in our daily lives. So, let's get learning.
Go.
So what exactly is an ellipse? By definition, it is the set of points in a plane such that the sum of the distances from each point to two fixed points is constant. So let's review it. An ellipse is the set of points. It's not exactly a whole number. It can either be a decimal or a fraction in a plane such that the sum, we all know that the sum is involved in addition. So plus plus plus. So addition will be the star operation in finding out the values of an ellipse. Okay, so continuing, sum of the distances from each point to two fixed points is constant. So an ellipse shows that one point to the next point, they are constant in measure. So with the definition done, we are going to learn more about the parts of the ellipse itself.
Go.
So we are here now to discuss the parts of the ellipse. So as you can see here in this illustration, I have already labeled an ellipse and its parts. So let's get going. First of all, there are these two little dots, and these are called the focus or the foci of the ellipse. So focus, or in plural form foci, is each of the two fixed points. So focus or the foci will not be disappearing from the ellipse because it is the fixed point or the star of the ellipse. Next, vertex, in plural form, that is the vertices. These are the intersecting points of the line containing the foci. So the line, this one, contains the foci and also the vertices. See how the foci and the vertices are placed near each other and they are located on the same line? That line is called the major axis. And the major axis is the line segment that is between the vertices. See that? That's the major axis. And also, there's also the minor axis, which is the line segment between the co-vertices. So, the major axis, the minor axis. See how they are different in length? That's why they are called major and minor axes. So the co-vertices here are the line perpendicular to the major axis intersecting these points. So the co-vertices are points on the minor axis. They form the points in which the whole ellipse will be formed. And the axes intersect at one common point, and that is the center. It is the midpoint of the two axes. So there are two different kinds of ellipses that are centered at different places. This is an example of an ellipse centered at 0, 0. And another example is it is centered at HK. But more on that later. And finally, the last part is the latus rectum or the latera recta. These are Latin terms used in mathematics. It is also known as the focal chord. This is the latera recta. Okay? So these are segments passing through the focus. It passes through the focus and it is denoted by the formula 2b squared over a. Now that you have learned the ellipses and the parts of it, we are now ready to learn more about its kinds. So here are the two kinds of ellipses, the vertical ellipse and the horizontal ellipse. So these are centered at 0, 0 or at the origin. For the vertical, the equation is x squared over b squared plus y squared over a squared is equal to 1, while for the horizontal, it is that x squared over a squared plus y squared over b squared is equal to 1. Always remember that for all equations of the ellipse, it is equated to 1. So the difference is when it is vertical, b squared will come first, while in horizontal, a squared will come first. So now we are going to learn more about centered at hk. Let's begin with the general equation of the ellipse. It comes in the form ax squared plus by squared plus cx plus dy is equal to 0. Take 6x squared plus 5y squared minus 12x plus 20y minus 4 as an example. See how it follows the pattern? So remember that the one with the exponents with the highest degrees come first before the other. Next, the standard equation of the ellipse. It comes in this form. So the example is x minus 1 squared over 5 plus y plus 2 squared over 6 is equal to 1. Make sure that it is equal to 1. Now, these examples are transformed from general. This is the standard. From the standard, this is the general. So to transform equations from standard to general, first multiply it by the LCD, expand and distribute values, and simplify and arrange the values. Next, from general to standard, all you have to do is group terms with x and y, factor out the constants, complete the square, make the right side equal to 1, and simplify. Okay, so here are the formulas for centered at hk. So for the horizontal, it is x minus h squared over a squared plus y minus k squared over b squared is equal to 1. For the vertical, just reverse the a and b, make it b squared first and then a squared also equal to 1, that you get the vertical. Okay, now you've mastered the different formulas for centered at 0, 0 and centered at hk. It's time to know the equations. So here are the practical applications of ellipse in our real life. So first, the sunburst window in churches and in homes. Next, it is in construction, especially when you are cutting a plywood into an ellipse. Next is architecture, as seen in a whispering gallery. Next is farming. When you plot your farm into a shape, you have to consider the ellipse as a suitable farming shape. And finally, it is seen in art, especially in various forms of art like painting, sculpture, and many others. So you have learned it all. Congratulations!